Hello everyone, I welcome you all in this lecture. So in this lecture we are going to visualize the Quadrotor Flight Simulation developed in that lecture. The name of that lecture was Quadrotor Flight Simulation. So in that lecture we have learned how to develop the quadrotor model, how to implement in a MATLAB and Simulink environment. And in this lecture we have already seen the plots, how the altitude to say varies with respect to the time and other states variable. Now in this lecture we are going to see, apart from plot, how will you visualize the quadrotor when it is flying. And also in this lecture we will try to connect the pilot stick with the quadrotor so that you can actually have a feel for a flight. Like for example, you can actually by putting the stick left, right, forward, backward, twisting along this direction, that direction, putting throttle at ideal and max condition, actually you can achieve the desired motion what you want. So in this lecture we will connect the pilot stick in the MATLAB and Simulink, as well as we will try to send the trajectory data to the flight gear. We all know the flight gear is a visualization kind of software where you can actually fly the aircraft like a simulator, and also you can visualize. That means you can deactivate the internal dynamics of a flight gear. You can model your own dynamics in MATLAB and Simulink and send only trajectory data, that means position and attitude, to the flight gear. Additional data also you can send, like control surface deflection, etc. I will show you. If you correctly remember, I have taken one more lecture. The name was Integrated Flight Simulation. There actually I have shown the flight simulation with visualization for a fixed wing aircraft. So in that lecture you can actually um, go and try to understand how I have connected the pilot stick with the Simulink model, and I have to discuss more about the flight gear also. Okay, so obviously that lecture will be helpful for you to understand this lecture. Okay, so again I'm summarizing here what we are going to do. We have already flight simulation quadrotor model. I have taken the lecture also. I will put the link in the description. In this lecture we are going to connect the Simulink model to the flight gear. We will send the trajectory data and we will connect the stick and we will fly. Okay, for example, we will give the uh, left stick like this and like that. Okay, so I will show you here. So this is the stick I have, Logitech stick. So I will map like this. For example, let's say if you are giving the left roll, so what will happen, the phi command will be generated. Similarly this call, so this in this case negative phi, this positive phi, and what about this forward, negative pitch angle, positive pitch angle, this positive psi, negative psi, and this one is throttle, ideal position, maximum position. Okay, so this actually you can design, to say, command variable with this pilot stick. For example, I have told you phi command, theta command, psi command, and with this throttle h command, and these command variable will go to the PID controller. Okay, and you have actual variable also. So the controller job is to minimize the error, actual minus, or commanded variable minus actual one. Okay, so that is how you will achieve the desired motion. So you can fly the quadrotor. Okay, so this is the way we have mapped this control pilot input, to say this is stick input, to the desired to say commanded variable, and then commanded variable will go to the um, PID controller. The controller will, the job is to minimize the error and achieve the desired motion. Simple example. when you want to take a, let's say, right roll. So what we will do, by using this we will generate the phi command. See, max stick deflection will be the max phi command. That way you can actually map max phi, max stick input, max phi. So here max is what, let's say +1. So +1 correspond to the plus 60 degree phi roll angle, positive. Okay, likewise -1 minus 60 degree. That way you can actually map. Okay, now when you do this, what is happening, the phi command is going to the PID controller, and what is the job of PID controller? Basically, if this is a quad rotor, so it is increasing the RPM of this two rotor and decreasing the RPM of this two rotor, and that is how you will take a roll. So this way you can achieve the desired motion. Okay, so it's time to go to the MATLAB and Simulink and develop the visualization platform for a quadrotor case, and later you can do for a multi-rotor case also. Okay, thank you so much.
So now we are going to see how our quad rotor will fly. We will visualize in a flight gear. Okay, so the same initialization file we are having here also. Already I explained to you in the Quadrotor Flight Simulation lecture about this code and all. So in this file we have initialization. Okay, and I again request go to that lecture and please see how I have written the code, implemented the code. Many things I have explained in that lecture. Okay, so here in this the purpose is for visualization. That means you connect this code, MATLAB code, to the flight gear and fly the quadrotor. Okay, and you are also aware of this Simulink uh, top level diagram where up to this part I have explained to you. Now I will explain here two part. How will you connect this pilot stick, and how will you connect this code to the flight gear? How will you send the trajectory variable? Okay. Before this, you can observe here, if you have a position x, y, z or h and angle, roll angle, pitch angle and yaw angle, phi theta psi, then actually you can say that ki how my model is behaving in a space, 3D space, right? So in a similar way, we will send x, y, z data and phi theta psi data to the flight gear, and to connect the flight gear, we have a pre-configured 6DUF animation model. So you can type here flight gear. So you will get this one. You can take this one, or you can take this one, and you can actually configure according to you. If you want to send velocity, control surface deflection, engine, landing gear inputs, environment, or you can also send a additional input to the flight gear. Okay, and in integrated flight simulation lecture also I have explained these things, how to connect, what is the purpose of a flight gear in detail for a fixed wing, but here we will cover in the multi-rotor. So again I also request to go to that lecture to understand more about the flight gear part. Okay, so one thing I am making clear here, I am not using flight gear internal flight dynamics. See, I have written the flight dynamics here, controller part here. So I am just sending the data to the flight gear. Okay, and in the folder when you open, when you run this run fg file, so this window will appear. Okay, this will appear. Okay, you can see that the quad rotor is there. Okay, by pressing the V button, actually you can change the view, the chase view without yaw, fly-by-wire view, tower view, cockpit view, helicopter view. So again I am explaining you actually make a CAD model in a SolidWorks and save in .wrl file and import this file into the AC3D software. And because flight gear will be supported by the AC 3D file only. FlightGear will take only AC 3D file. Okay, and then you can put this file in a FlightGear folder. Inside the FlightGear you will have a model HL20 folder where you can name it as HL20. Okay, this way when you run fg.bat, the FlightGear model will appear. Okay, like this. Okay, so you can see this India is written here, right? I'm You can write any country name or whatever you want. I have written India because I am from India. Okay, side by side, right? So that when you fly you will see. So I prefer chase view. Okay, now I will explain little about this stick part, how to connect. So already I have explained to you in that lecture, so I request go to that lecture and integrated flight simulation. I will put the link in the description. So I will put the two link in the description. First link, if you click you will see how the code is written, and second link will tell you about how to connect this, what is the purpose, how to connect this pilot stick, and detail about the flight gear part. Okay, so you can see this uh, here by deflecting the stick actually. So what we can say here in a very simple manner. So here you can see this stick. So the connection is like that. When you take a stick left, the quadrotor will bang towards left, similarly in the right direction. And when you put the stick forward, the quadrotor will move forward, that means pitch down. And when you do this, that will become the pitch up motion of a quadrotor. Okay, similarly this is a left right yaw, and this is a left yaw, and this is a zero thrust, this is a maximum thrust. Okay, so you can see that phi command, theta command, and the third one is a throttle one. So when you change the throttle, the third throttle is mapped with the altitude command, and the last one is mapped with the psi command. Okay, so again I will explain here. When you do this, phi command will be generated, negative phi, positive phi, that means left roll, right roll. And then when you do this, pitch command will be generated, negative pitch, positive pitch. And when you do this, altitude command will be generated based on thrust. And when you do this, the psi command will be generated. Okay, positive side and negative side. Okay, and you can change the mapping easily, that is not a problem, I mean to say. Okay, so this phi command, theta command, h command, and psi command, where it will go? It will go to the controller block. Okay, h command, phi command, and this is theta command, and this is psi command. Okay, psi command. Okay, so rest of the things will remain same only. Okay, rest of the part which already I explained to you in the Quadrotor Flight Simulation course. So here two things is new. One is stick connection. Although stick connection I have explained to you in the integrated flight simulation course, and another is the flight gear part. But the new thing is this stick and flight gear part we are doing for a multi-rotor case. Okay. Now it's time to run the simulation and let's see what will happen. Okay. So you can put 1000 seconds, not a problem. So you can see how my quadrotor is flying. So you can see when you do this, you can see when you put this throttle down. Okay, so the quadrotor will go down. Okay, so again we will run the simulation. You can see here. when I am putting throttle up, the quadrotor is going up, right? I can reduce in order to hover some altitude. Okay, and then you can see when I am taking left, it is going left. Okay, right. Okay, forward motion. Okay, and the pitch up motion, and this is here, and this is right and left. Okay, now now we can actually run the simulation again. You can see this, the quad rotor is going up. Okay, and now I am going forward. Okay, if you want to fly close the ground, you can actually reduce the throttle, and then you will feel that how my quad rotor is moving forward. Okay, okay, now almost close to the ground. Now you can see. Now you can see how my quadrotor is moving forward. Okay, and if you take a left roll, you can take a left roll also. Okay, and you can actually do some coding, and you can make the propeller rotating as well. So little extra thing you have to do. Okay, you can see the some plots also, how this, see, you can see altitude, right? Important one, you can see where my altitude. Okay, so if I am putting the throttle, let's say if I am putting the throttle, let's say this is idle and this is maximum I'm putting, so you can see the altitude is going up, right? Up, right? Okay, if I reduce, the altitude will fall. Now it is falling. Okay, you can see in altitude directly plot and also in flight gear. So this way you can actually control the altitude. Okay, okay, and if you want to see another plot, you can see phi. I think you can see there is a no roll as of now, so phi is 0. You can see there is a no pitch, you can see phi is 0. And let's say if you want to have some pitch down motion, you can see how my pitch is going down. Okay, see, I am putting the pitch down right here, you can see how the pitch down and then pitch up. Okay, so likewise you can actually have a roll also plot. So all the plots in the flight gear as well as in the Simulink you can see. So this indicates that whatever things are running in this is running in a real time. I am not using already inbuilt dynamics in a flight gear. We have written our own, and the flight gear we are using just for a visualization. Okay, so if anything's related, if you have any doubt, please ask the question. Okay, now in full I will stop the simulation and the full screen I will run the flight gear. Okay, so you can see how the quadrotor is taking off. Okay, and now I will try to control some altitude. Okay, I will try to control some altitude. I will bring the quadrotor down close to the ground, close to the ground, close to the ground, close to the ground, and then I will give pitch down motion, and you can see the quadrotor is moving forward beautifully. More pitch down, more forward. Okay. Full pitch down, close to the ground. Okay. Now similarly, when you release the stick, the quadrotor pitch will become 0. So that is a beauty of for flying this kind of mode. And when you take a roll, see this full roll. Okay. And during the roll, make sure you should not have some kind of twist, otherwise you will achieve different kind of motion. So if you want to pull one pure roll, you have to be very careful for deflecting this roll like this, otherwise some kind of yaw will happen. Okay. So all right, if you have any doubt, then we'll meet. Okay, I hope you have liked this lecture, and I will be happy to answer if you have any comment. Okay. And you can see this is in the flyby view, you can see how my quadrotor is flying. Okay, perfect. See this. Thank you so much. We'll meet in the next class. Okay.